behalf of the Royal Academy of Engineering to welcome you to our 2008 Awards Dinner. Tonight, we celebrate some truly remarkable engineers who've made their mark on society through great ideas turned into great engineering. We think that engineers should be centre stage in public life, applying their skills and putting forward their perspectives to address the major challenges facing the world today, whether it's solving climate change and finding new, clean ways of powering the world, putting an end to poverty, or defeating the scourge of preventable ill health. Engineers have a big part to play. So I'd like to particularly welcome our younger guests here this evening, our awardees, presenters, the young engineers from our sponsoring companies, and the young engineers representing academy programs. Engineers design the future, and you are the future of our profession. Your energy, ideas, and ingenuity will serve the world well, and I'm sure that you have decided that if you want to change the world, you become an engineer.
The McRobert Award is the UK's most prestigious prize for innovation in engineering. It is awarded annually for the demonstration of engineering excellence and innovation, proven commercial outcomes and benefit to the community. Each of this year's finalists has developed and executed a unique engineering innovation that will have a major impact on the well-being and prosperity of society.
It's my great honor to receive the International Medal of the Royal Academy of Engineering. I will continuously do all my best for the further strengthening of the cooperation relationship between China and the United Kingdom. Thank you very much.
Thank you. Thank you very much.
Our winners and our brilliant award donor, Emily Cummins. Once more, our young nominees from our sponsor companies. Well done all.
The Technology Horizons Award is a partnership of the Royal Academy of Engineering, the Independent newspaper and Bosch. The key successes of this year's competition, we have seen 500 entries from all over the country, from schools and universities, and we have seen really good quality. The competition is important for Bosch because Bosch as a company is driving change through innovation. For example, the electronic stability program is saving lives. The start-stop system is reducing fuel consumption. We want to make young engineers and students aware of Bosch as a leading technology company. With our 270,000 employees around the world, there are huge opportunities for young people to start a career in engineering within Bosch. Young engineers have in today's world huge opportunities. They can contribute to the future success of a company and of a country.
I entered the Independent Bosch Technology Horizons Award because it was a topic that interested me, and it also gave me a chance to have my work published in the independent newspaper.
I learnt about the competition from Future Flight magazine, so I thought, okay, this seems interesting, and I went for it, yeah.
I chose China as my topic because it is a topic that's in the media at the moment a lot with the Olympic Games. It's also known for having a second industrial revolution at the moment. I talked about the world's first eco-city, Dongtan, which is being built in China. I also talked about hydropower, which China are harnessing at the moment.
I chose China because, well, over the last 20 years, you know, you've had staggering economic growth from this country, and things have changed so dramatically in the country. In my essay, I talked about solar power in China, you know. There's a lot of controversy over things like carbon emissions from the country.
Engineering is at the very heart of Sheffield University, so I'm sure that when people hear about my win, they will be a lot more encouraged to enter the competition next year.
The benefits for the students who enter the competition are threefold. First of all, there's a nice cash prize. Secondly, the winner gets published in the independent newspaper. And finally, people get in contact with exciting new topics in the world of engineering, and hopefully find this attractive to start a career in engineering.
For me, winning this competition, it was really exciting. For career prospects and university applications, it will be really, really useful, I think, to have an award. And the money doesn't hurt either.
I think other companies should follow Bosch's example and give young people a chance to have their say about technology and innovation in the future.
Christopher and Carmel, ladies and gentlemen, and Robert Meyer again. Thank you very much indeed. Please welcome the Senior Fellow. This year's Prince Philip Medal goes to Ron Dennis, Chief Executive of the McLaren Group. Mr. Dennis.
We don't have just engineers, we have scientists. We are one of the premier motorsport teams in the country, in the world, but we do so much more, and I'm just so tremendously proud to be part of it. And whether you succeed or fail in this very competitive world, the most important thing to remember is without the passion for excellence that my people have, the success, this award would be impossible. Thank you very much.
without further ado, the winners of the 2008 McRobert Award are Touch Bionics.
It's a great honour for Touch Bionics to be shortlisted for this award, to win this award, and from all the men in skirts in this audience, we would like to say, particularly in light of the competition tonight, which is a great future for engineering in Britain. Moreover, we're competing on an international stage and showing that British engineering is at the fore of medical device development. And on behalf of Stewart, Nikki, Hugh, Phil, Stewart and myself, we thank you for the recognition of all our efforts, and we wish every success to the endeavours of all our competitors tonight. Thank you very much.
The McRobert Award is Britain's premier award for engineering innovation. It was originally established in 1969, and for the past 40 years we've seen a succession of really outstanding British innovations. Well, the McRobert Award is open to any company in the United Kingdom, from the smallest 2 or 3 person organisation up to big multinationals like IBM or Rolls-Royce or British Aerospace. They've all been entrants in the past. The award is based on 3 criteria. The first and obvious one is innovation. But we also look for commercial success, evidence that the innovation is being actually used by people in their day-to-day lives, and for benefit to the community. All 4 finalists have shown a tremendous talent for innovation and bringing that innovation to commercial success. I wish them every good luck for this continued success in the future.
Polar is a very large-scale robotic store which has been designed to store biological samples for a 20-year period. In 2005 we were approached by the UK Biobank, which is an initiative to study disease, look into the causes of heart disease, diabetes and cancer, and they wanted us to automate the storage and retrieval of very large quantities of biological material. There are a number of innovations behind Polar, but the principal innovations are the way that we robotically access the samples, which are stored at a very, very low temperature without compromising the samples themselves or the reliability of the robotics. The first commercial success for the company was being awarded the contract for the UK Biobank. Since then we've been working with a large number of research organisations and pharmaceutical companies across Europe and also in the US, where typically we do 70% of our business. We hope that Polar is going to have a very positive impact on healthcare in the future. Polar will enable the UK Biobank to issue samples to researchers who are looking at the underlying causes of disease, and that research may lead to treatments or even cures for diseases such as heart disease, diabetes and cancers. The engineering behind Polar is truly multidisciplinary. So we've got robotics, refrigeration and software. And one of the things that we believe is particularly striking about this innovation is that we've excelled in all 3 areas. I believe that engineering is pivotal to providing healthcare solutions. The sequencing of the human genome was made possible through engineering innovation. It's tremendously exciting for the company to be nominated for the McRobert Award. It's a recognition of our innovation over the past 10 or 15 years to be finalists. We recognise that the McRobert Award is one of the premium engineering awards in the UK, and for TAP to win such an award would be a recognition of the innovative nature of our business.
Diesel cars are very popular in Europe at the moment, and that's because they are very fuel efficient and they're fun to drive. The challenge with diesel cars is that they do have some health concerns associated with the soot that they produce. The innovation of Johnson Matthey is to combine all the functions of the previous multi-component soot filter systems into one small unit that fits inside the engine compartment. This is the Johnson Matthey compact soot filter that is so small it can fit directly on the engine, fits onto the turbocharger, and there it can use all of the heat from the engine to remove the pollutants during normal driving. The soot is retained in the filter and it has to be removed, and it's removed by taking the temperature up by putting extra fuel into the engine, which is burnt over the catalyst, and then the temperature is in excess of 600 degrees and it burns the soot in a very carefully controlled way. Here in Johnson Matthey, engineers, chemists, physicists all work together as a team, and it's very difficult to differentiate between whether somebody's an engineer, a chemist, a physicist, or whatever. The quality of the air has been improved over the last 30 years. In America and in Europe, catalysts were first fitted in 1993, and since then the engines have become cleaner and cleaner, but there still remains this problem about the residual soot from diesel engines, and filters, and particularly our compact filter, removes all of those problems. We have done something that is very good, beneficial to society, and very beneficial to the country. It would be wonderful to win the McRobert Award. We won it in 2000, and it is a prestigious award, and it gives recognition to all of the people that have been involved in a particular project.
We've developed a miniaturized chemical sensor, so something a bit like an electronic nose. You can see it's a very small, low-cost device, so you can build things which are a bit like a smoke detector for explosives. The two main areas of application for the device we're focused on now are security and industrial applications. So in military and security, it's government clients, so people like the Department of Defence. Then on the industrial side, we tend to focus on large blue-chip industrial partners. The key aspect here is the innovation. Around the country now you have systems used in airports which aren't really fit for purpose. So we've been able to take those devices and shrink it down to a silicon chip and completely change the way in which we can deploy these technologies. On human breath you have a lot of chemicals, some of which can be indicators for disease and illness. So you can actually program our device to look at those chemicals as a way to very quickly and accurately diagnose disease. We can actually use our device to make sure during the manufacture of food and consumer goods that it's at the right flavour levels and the right odour levels. In this setup here what we have is a range of simulated chemical attack gases, so things like mustard gas and chlorine. What we can actually do is introduce it into this glass bottle and simulate what would happen in a real world chemical attack. We now use our instrument here, Lone Star, which contains our microchip chemical sensor, to take that gas in and analyse it so we can detect those chlorine gases. Existing systems, benchtop systems, false alarm quite a lot. An example is Chanel No. 5 smells like sarin gas to these large instruments. One of the key advantages of our technology is the fact that we can completely eliminate these false alarms. Here in Alastair we have a range of engineering and science disciplines. So the heart of everything is the silicon chip. So we have silicon engineers designing and developing that device. And then around that we have electronics and mechanical subsystems, and then that's all embedded into the overall product which is sold to our customers.
The company's technology originates from the NHS, and it was spun out from the NHS in 2002 when a private company, Touch Finance, was formed. There's two main benefits for patients in the ILM hand. The first is obviously they can do more activities of daily living, they can do more functions with it. But the second and probably the biggest driver is the fact that it looks so much like a human hand. The ILM hand is a fusion of different disciplines, including mechanical engineering, electronics, software, and of course plastics and materials. So the thing that makes the ILM hand unique is that there has a motor in each of the fingers and one in the thumb, and that motor drives a gear here which gives us the first articulation point. The second articulation point here is driven by a belt, much like that tendon in our own hand. This means that the hand can actually comply to the shape of objects, or conform to the shape of objects it's gripping, such as that. The second very important part of the hand is that the thumb is movable through different grip positions, just like our own hand is. And that's very important because the thing that makes us so dexterous is the fact that our thumb can oppose our fingers. Well, if you look at the existing market leader for prosthetic hands around the world, it's this device here, and as you can see, that's clearly limited in both function and in its appearance. I think the key success for the ILM hand has come about through the fact that we engaged with customers very early on in the design process. In fact, some of the customers were involved with us over 3 years ago. The hand has been very successful in America, and it's now being accepted widely across Europe, but we actually do sell a hand today in 22 different countries.
I was the first person in the world to have the ILM hand, and I've been involved with Touch Bionics for the 2 years in research and progress to bring it to what it is today. The ILM hand has changed my life, mostly because it's so easy to pick up things, cooking, painting. Just the fact you can move all the fingers makes it much easier.
We're delighted to be finalists in the McRobert Award. The process has been very stimulating for us, and we've had quite a few learnings along the way. If we were to be the final winners, of course that would be great recognition for all the hard work that the team put in.